In 7, it was talking about angles AOB, BOC, and AOC. Which means, in this case, do I need to worry about that ray with the D on it? No. And I think I made the suggestion to you guys to go ahead and redraw that, so that way you guys could see the other angles clearer. Okay? Here's what I meant. You don't have to draw these things to be perfect. You just want to draw them so you can see them. Relabel it. A. Oh, sorry, C was up here. C. So C, O, B, and A. All I'm doing was just making those other two angles larger. Now I can see what the heck is going on. Because we agreed that that ray OD had nothing to do with the problem at all. Okay? And I do the exact same thing with the second set of problems, because then it doesn't deal with OA because it goes the other way. What they were doing here, guys, is they're just showing that they're using one diagram for multiple problems. But apparently, that's a little too much. And this is better fill in the blanks. If you know AOB is 4x minus 1, BOC is 2x plus 15, and the whole thing, 8x plus 8. Does it say anywhere that those two smaller angles are the same?
No.
No. So do I set them equal to each other? No, not at all. But it does say that I have two smaller angles that add up to equal the larger one, doesn't it? That's what you would write out. So what we're looking at is, you can do it a couple of ways. Remember when we first started talking about angle addition? I always said, hey, just write it out. A, O, B, oops, plus angle BOC equal the larger angle C. And then aren't those the values that they gave you? That's what you're looking to be able to do, guys. Can you take the bits of information that they're giving you and throw it visually so you can see it better? And that's the easiest way to set that something like that. Okay. Yes, ma'am. What's that? I'm sorry? No, that's just dumb luck. It's just dumb luck that this is how it worked out. I could have written it as COB plus BOA would have equaled COA. And just remember, the angle lettering, it just does, as long as the vertex, the middle letter, is the same, the direction that you're reading it is the same. Okay? They can be flip-flopped, just like with segments. Segment XY is the same thing as Y, X. That doesn't matter. So yeah, this is just dumb luck that it worked. So we fill it in. 4x minus 1, 2x, and a 15 is 8x plus 8. And all of a sudden, it looks just like every other algebra problem we've been doing for the past week, where you have bits of variables, numbers, combining like terms, variables on both sides. Okay. So as we do that, what's 2x and 4x?
6x.
Good. Negative 1 and 15. You're right now. 6x plus 14 is 8x.
Well, I mean x, right?
I believe so. This one was just solved. I think it said solve for x with the instructions on it.
Yeah.
Variables on both sides of the equation. Who are you going to pick on?
The little guy.
Good. Subtract that 6x over, and you get 14 is 2x plus 8. Once again, swing that 8 back to the other side. 14 minus 8 is?
6.
You get 3 for x. 8 is the exact same problem. The only thing that changes is that you're using a different diagram. You do the exact same scenarios, exact same setups. Remember, guys, a lot of this stuff is all the same. It's just, what are you looking at? How do you set it up? Right. How'd you do on 9? 9 was supplementary, right?
No.
Oh, vertical, thanks. So what do vertical angles look like? What do we do for that? The diagram. Good, good. You do the diagram. Remember, when you're doing and working with the diagram one for 9, this one here, there's one or two things you can go about doing. What don't you see? A drawing, a picture. Draw it. We know what vertical angles looks like. Oh, we didn't write that down. Remember when we defined it? Well, complementary was the sum of supplementary. What was different between than linear pair? They're always together. Very good. And they created a. They're always together, and they create the line. So angles 1 and 2. They still add up to equal how much? 180. And then lastly, when we talk about vertical angles, it was always easier just to draw the picture and put the tick marks in, instead of writing god-awful definition. Okay, so you know that those vertical angles will always be. So if you know and they tell you that they are congruent right away, could you just set them equal to each other if you want? Or could you label and draw a picture and then realize, oh, that's what that means? Either one is fine, guys. It just depends on what you remember. Remember, most of the geometry that we're doing is based upon definitions that you just reuse algebraically. So if you keep straight your definitions, the algebra becomes a piece of cake. Okay? Well, if I draw it, let's see, A, B, C, F. Well, there's your shared stuff. You know that they have to be the same. 3x and 8. And 2x is 48. Throw them equal to each other. This one's really fast. Can I do both steps at once? We'll be okay with that? You guys done that before when you have variables on both sides and you just do both at the same time? Do you have to? Sometimes it's quick, like this one, there's not much to it. I write it out. Subtract the 2x from here, subtract the 2x from here, subtract the 8, subtract the 8. Dun, dun, dun. What's up? Well, then don't do it that way. Don't do it then. Forgot about it. Now what do? Yeah. All I did was I'm just saving 8. Okay. Did it say solve for x or did it say solve for the angle?
It just says solve for x and find the angle.
Oh, then find the angle measure. Okay. What's that? I just said it's the same thing as 7. So take the 40. You're substituting back in here and here. Hopefully, you should get the same number. Well, what's 3 times 4? Add a 0, you get. Add 8, you get. 2 times 40. Add 48. There you go. We were just trying to do it mentally. DOC. This would be 8 when you set it up. All I'm doing is I'm redrawing just the 2 angles that they're talking, or excuse me, the 3 angles that they're talking about. I'm drawing it larger so I can see it better. Does it say anywhere in the instructions that any of these angles are the same?
No.
No. Remember, if it doesn't say any of that, you can't assume any of that. All right? What we do then is just fill in the blanks with the information given. COD, 8x plus 13. BOC, 3x minus 10. And the entire thing, 12x minus 6. This is the scenario. Now, you just asked me to do the problem. Are you doing math on that, or are you texting somebody? Getting angry for a second. Make sure you have a calculator for tomorrow because you won't be able to use the phone. Goes for everybody. All right? So you know. Yes, sir. Sir. Good conversation. So from here, algebraically, you know we've got two smaller angles that add up to equal to large, so you write it out. And it's back to the same generic setup. Combine your like terms, you get, what is that, 11x and a 3? Yes, ma'am. The order? What do you mean?
Yeah.
You mean which one of these I put first?
Yeah.
What do you mean? Show me. Just by drawing it? Oh, you draw it. Just draw it. Well, when you're drawing an angle, the middle letter is always the other two letters doesn't matter. Remember, when you have a segment, does it change if you walk from X to Y versus Y to X? If this distance is 13 feet, would this distance be 13 feet? Same idea if you're an angle. If this is X, A, B, C. Does it matter if I start from A, the angle right, get to here? Angles don't have distances, but they have degree measures. So if I'm going from here and making an 80-degree turn here, it's the same thing as starting from here, making an 80-degree turn here. All the lettering tells me is what direction I start. Okay? That's all that means. It means the exact same thing. Come back this way because it's still the exact same value at what we call that vertex, where it changes direction. It's the same thing. Shh, guys. All right. The reason that we worry about how the lettering goes is that eventually when we get to triangles, we start proving triangles. We're going to follow a specific order around the triangle via tick marks to help congruency and stuff. Okay. So just remember, all this means is where you start, where you end. Same idea as a segment. You start at X and then Y. Start at Y and then X. It's the same segment. It's the same angle. Questions? All right. So back to here, subtract the 11x, you get what? You get x, and you add the 6, you get.
No, I'm not there. I'm past that. I think I just said yes.
Well, you said -3.
That's what I got. 8.
Did you accidentally write this as a +6?
Probably.
Yeah.
You did 3.
She get 9.
Oh, I know she did. She subtracted another day.
All right. 10 was the one that I believe that said supplementary, didn't it? Complementary. All right, for complementary, what did they add up to equal? Okay. Back again to a two-step equation. Set equal to 90. Pretty quick. On the other side, you had. What was it? I gave you a couple of the angle bisectors. Remember, we did ones just like that in notes in class. So, which number did we do on there? I forgot which number it was. 18? Let's look at 18 real quick. You're using the same basic idea. It says that ray QS bisects the angle PQR. So if I'm labeling PQR, does it matter if I start at PQR? Can I go PQR? Does it matter? No, because where is QS still going to come out of? It's still going to come out of that vertex, right? Exactly. It's still going to come out of the vertex. So it doesn't matter where you put it, because it still works. So I start with my angle. And like I said before, more often than not, I overdraw things so that I have room to see it. Okay. From there, I just draw that bisector, that angle bisector. Remember, angle bisector is kind of like a midpoint, but there's no way to put a point in the middle of an angle. They have to make an extra side point, so that's why they use an extra ray. Fill in the blanks. PQS, 2x plus 1. RQS, 4x minus 15. Angle bisectors cut an angle into two equal and congruent parts, so we put our tick marks in, which therefore means, what do I do with the algebra? Exactly. Do you guys see the difference between setting them equal to each other versus adding them together to set them equal to a value? Well, do we know what the whole angle is at all? No, I don't have that information. I can't do anything about it. So I have to just set them equal to each other in this case. So it's 2x plus 1. In this case, then, we do what first? Subtract 2x. And last but not least, well, not last, but close, but almost least. And it gives you an 8. The instructions then said to figure out what PQR was, I believe, for the whole thing. Well, remember, what's nice then is that you can take a second and make sure that, well, if x is 8, what's 2 times 8?
16.
Plus 1.
17.
Okay. 4 times 8.
32.
Subtract 15.
17.
Does 17 equal 17? Yeah. That's a good sign. That means we didn't done goof. Then you screwed something up. Double check your work. Add it together, you get the whole angle is equal to 30. Remember, geometry is going to have you do it's going to start with a geometric term, switch back to the algebra, and go back to the geometry in the end to put the parts back together. All right? That's straight. And then I think the last little one on there was what, number 25, I believe? 25 was the exact same thing as the complementary one. 25 would have been the same thing. I think it said, let me read this real fast. 10. Thank you. It's the exact same thing as 10. It just tells you you've got two complementary angles, which means they have to add up to equal how much?
90.
There you go. The only thing that was different with 25 is that they asked you specifically to label out all the parts. It's something that we do anyway, but they were actually having it written out in long form. Okay? So when you add those two together, take a little clean one. Let's get caught up. Excuse me. Thanks. I appreciate the okayness of my yawn. Yeah, open house was last night. It was exciting. You know, I was here until 8:40. It was weird. Old, tired. So we know by definition. Just by definition, tells you they're complementary. Write down what that means. Angle plus angle equals 90. Remember, complementary angles don't necessarily have to be sharing the same vertex. Remember, they can be in two separate spots. Sometimes they are, sometimes they aren't. And you know what they are then? 7x minus 1. Okay. So we get what? 11x plus 2. Subtract the 2. And not every answer is going to equal 8. And then just go back and forth. The reason why it says solve it or show how you can check your answer, well, once you get your two angles together, what should your two angles add up to equal? That's what it means, guys. If it doesn't, that means you should double check the work. Okay. Not too terrible. I think what's really going to be an issue is when you guys have to understand how you start the problem. Okay. And what came up with yesterday is that it came up with this nice little review sheet that I want to go over with you guys and talk about how we're going to set this stuff up for tomorrow. So, quiz stuff tomorrow. We've got sections, 1, 2 through 1, 5. And I want to talk a little bit about the different sections and the different parts and kind of give you guys a little heads up on things. If I were you, I would make sure I spent a little extra time on it. Tomorrow's kind of a bunch of paperwork. Tomorrow's going to be a little bit extra paperwork. Instead of doing the whole, I'm going to have you guys, remember how we were originally going to quiz today, do the homework check tomorrow? Well, instead of doing all that homework check stuff at the same time as the quiz and whatnot, what I'm going to do is collect this homework sheet that I just gave you as the homework check. You won't know what 4 problems I'm going to randomly select to check for the answers, but I will. Correct. But here's the thing. I'm going to spend time going over a bunch of little bits and pieces of the different sections and parts out of here. When I did that during the second hour, I got through about half the problems. Okay? You'd be surprised at stuff how repetitive some of these things are. So, section-wise, your quiz is over the 1, 2 through 1, 5. Now, don't pay too close attention to this one where it says section 1.1 on the other side. It says 1.1. And you probably noticed that there's like 5 different number 5s on this sheet, or at least 3 of them. This is called a Vitoni special. None of you guys know who he is, but we had a teacher here, bless you, about 8 years ago, Mr. Vitoni. And a lot of times he, when he would make quizzes and tests and stuff, he would just take old problems and instead of retyping it, He would just cut them out and tape them, put them on a piece of paper, make a photocopy. It's called the Pittoni Special. It's wonderful. So I went through it and took some of the older worksheets out of the old textbook, which I think are better than the new ones, and piecemealed it together with some good algebra questions and some good stuff out of there. So don't pay attention if it says 1.1, 1.4. These section numbers around here are a little bit different than what we've already done. All right. In section 1.2 is mainly kind of a lot of vocab. What's a point? What's a line? What's a plane? How do you label things? Stuff like that. That's kind of what all this little top part here of this 1.1 asking about the trues and falses. For example, it says points H, I, and G are collinear. Is that true or false? Well, that means, bless you have to remember what in the world does collinear mean? Same line. Good. So you look at it. Are points H, I, and G on the same line according to this diagram?
Yeah.
All right, so the answer is
Yes.
yes. Yes or true? No. Of course, you can write on this. When it gets to the algebra stuff, you're going to want to do extra sheet of paper.
Okay.
So, yeah, you can write all over this, but you're going to want to show your work from the other stuff as we get to the algebra on a separate sheet. There's no room to do it. Okay. As you got into 1.3, we started talking about segments and segment addition. What did segment addition mean?
You add a segment.
Add the segments and get...
Add the small segment, and get the big segment.
Right. Are all those segments always going to be on the same line? Is the points on the same line, though?
Yes.
Yes, they have to be for segment addition. Okay. So segment addition was this. If this is 3 and the whole thing is 11, how much is YZ? 8. In basic terminology, when you're dealing with segment addition, just like you said, small segment plus small segment equals big segment. Could it be 2 segments? Could it be 3 segments? Could it be 8 segments? As long as they're collinear, it doesn't matter. Remember, collinear, same line. Okay. So let's look at, also in here, in 1.3, we talk about segment bisector or midpoint. Bless you. What does a segment bisector or midpoint do to a segment? Splits it in half. Very good. It cuts this segment into 2 equal congruent parts. So I'm going to skip down here about halfway down, about number 6, where it says find UV. Everybody see that one? It says diagram M is the midpoint, find the indicated length. Well, if this is U, M, V, this is 21x minus 13, 10x plus 31. If I know that's a midpoint, what do I do algebraically to figure out what x is? Exactly. Set them equal to each other. And the reason we do that is because we see we have tick marks. Tick marks denote that they are going to be
Equal.
All right. Pick on the little guy. Who are you going to move, a 21 or a 10?
Okay.
You can, but if you start moving all those, you feel all the negatives. It just hits. So you move the 10x, excuse me. You get the 11x minus the 13 is 31. Good. Now you add 13, because it's the opposite of subtraction. Bless you. And what do you get for x then? 4. Really easy. Okay? Really easy. Now, the question doesn't just ask for, hey, what's x? The question asks, find the segment UV, which means how many times do you have to substitute in for x? Twice. Good. Well, take your value of x, and you substitute in. Well, 21 times x sounds like it's going to be awful, but what is it? What is it? 84. Good. 84 subtract 13, you get 71. 40 plus 31 is also 71, which makes the whole thing a number. Very good. Can you make it a little bit more, a little bit closer? You can do 71 plus 71. Brain hurts. Yeah, you're right.
No.
Flip over. Flip over to the other one real quick. Flip over to the other side where it has this awful looking T looking diagram. Remember the suggestions that I've talked with you guys many times about? Whenever you have a diagram that has multiple parts to it, never read the questions. Always fill in the blanks on the diagram prior to doing anything. It makes everything easier in the long run. For example, it tells you that you've got collinear points A, B, C, D, and then C, X, Y, and Z. Okay, great. The next line says you've got a bunch of segments that are equal in length. So in the diagram, what am I going to put? Tick marks. Good. A, B, B, C, C, X, Y, Z. Those four segments will all equal the same amount. Don't know what it is yet, but I know they have to be the same. I know that this whole chunk is 54. And I know that this chunk in the middle here is 22. And I also know that this portion from here to here is 33. That allows me now to be able to figure out YZ. Everybody see how if you don't pay attention to anything else here, you just look at this portion. Chunk plus chunk is the larger chunk, yes.
Okay.
22 and what is 33?
11.
11, good. Breaking it into smaller pieces to make your life easier. Don't get overwhelmed when you see a big picture diagram, because all you have to do is just cover up some of it and it falls into place super fast. So now if you know that that part is 11, what's this part? What's this one? Okay. What's 11 plus 11? 22 plus what is 54? Very good. Now, what you just did there is that you just looked at the diagram itself, filled in all the blanks. Can't you just read the questions from there? Well, you can. That's the idea, guys. You go to a big picture diagram, you fill in all the information before you ever once look at one of the questions. I guarantee if you start going into the questions first, you're going to get lost in the diagram. It's so much, turn it off. So much easier to do it this way. Okay. While we are still on segments, go to the question right below that. What would that be? Number 25. It says find the indicated length. Find the segment ST. Well, is this a midpoint problem or just a segment addition problem? Very good. Why is it segment addition and not midpoint? Correct. And you would also have what written down? You'd have one word midpoint sometimes, or you'd have, someone said it, the tick marks. Yeah, exactly. You might have tick marks. Do you see any of that? No. No. So what do you write out? 4x plus 12x is, step ahead. You were saying 8, 24. Okay. Just making sure. at 29. Same deal again. What does 29 not have?
A picture.
A picture. So what do?
Draw one.
Draw one. All right, which means you have to understand what the words say. It says point J is between H and K on segment HK. Does it say midpoint? Does it say anything? What does it say? Exactly. Okay. So what do you need to draw? What are my endpoints?
H and K.
Where do I put J? Does it have to be in the middle? Does it say it's in the middle? Somewhere between them. Does it matter where I put it then? It doesn't matter. I don't want you to put it in the middle because then you might think, oh, they have to be equal. It doesn't say that. All right. Now it says this HJ is x over 4. That's weird. That means it's x divided by 4. That's 1/4 times x. Right? This is 3x minus 4. And the whole thing is 22. I wanted to show you guys this problem because we haven't had to deal with a problem yet that had fractional amounts like that written into it. What is 1/4 as a decimal? It's a quarter, isn't it? 1.25. My suggestion is to write it like that because it means the same thing. Because on your calculator, you got a decimal button that's easier to press than it is to create fractions. Okay. Do you all agree that still has to be second addition?
Yeah.
Small one plus small one is the large one? It just means the same thing. I'm going to still write it out as 0.25x plus 3x minus 4 is 22. What's 3 plus 0.25? Exactly. Don't you have a calculator that'll do the rest of this for you? Well, if you had your calculator, you'd be able to do that? I just wanted to show you that. So, what haven't we talked about on this sheet yet? The angles. Went through all the segment stuff, so let's go back and look at the angles. The middle of the first page, questions 10 and 11. Says find the indicated length, or sorry, find the indicated angle measure. Does it say anywhere in those problems that the two angles are equal to each other? Right, it tells you that the angle plus the angle has to be the whole thing. It should be, it might be, I don't know. There's no difference between this problem and the second problem. There's no difference. How do you get the number? The exact same way. If I know that the entire angle is 94 degrees, I know that 3x plus 15 plus x plus 7 has to equal 94. The worst case scenario, they could say that this is equal to 8x plus 2. And then you have to set it equal to 8x plus 2. You know what I mean? If it doesn't tell you what the whole thing is, then the only way to be able to figure that out is if these were, in fact, bisected. Because if they were bisected, that's all you have to know, because then you just set them equal to each other. If you don't know that, so I wanted to show you that. Which is, again, notice how all the algebra problems we're doing here are the same thing over and over again. Okay? Look at the bottom of that page. The bottom of that page talks about what? Talks about angle bisectors, doesn't it? Now, do you see the difference between how it's written? BD bisects the angle. The whole angle equals this, and here's the two parts. It is that vocabulary, that verbiage, if you will, on how it will be explained so that way you know what to do. Okay? That's the idea. Can you read? I know it's not a reading class, it's not English or humanities. It's not that. But unfortunately, math has vocabulary, a lot in geometry. So for like number 17 down here, since it's a bisector, I would in fact have to set them equal to each other and solve it out. So 5x minus the 11 is 4x plus 1. Super fast at that point. Okay? Super fast. On the other side, if you look at the other side, don't these look like the ones we did 2 days ago for homework?
Yeah.
They're not the same problems, but they mirror the exact same thing. What do you know that 2x and the 3x minus 10 have to add up to equal?
90.
Why?
Because the other side is 90. And
Excellent, 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 excellent. Okay. What about these two? 6 and 7. What do those two have to add up to equal?
180.
Because they're what? Line. They are linear pairs. Very good. I'm sorry, what? Yeah, because it's a little square box. Okay. And then the last ones on the page also we did for homework a couple of days ago. Obviously these numbers are a little bit different. Just revert back. 28x, 24x, they're on the same line. They have to add up to equal 180. Substitute back, use your vertical. All right? Guys, if you've got questions on any of these things at all, work through them, work through them, work through them. I will collect this along with your work on these tomorrow. We'll take our quiz. The quiz itself, I think it's like 9 or 10 questions. But obviously, I'll have you substitute back in and find parts. But I don't believe shouldn't take you more than 25 to 30 minutes tops. Yes, sir. Yeah, I'll have you. I want to see your work though. Make sure you show your work. Yeah, well, that's cool. All right. Sound good? Remember, you gotta have a calculator tomorrow. Go phones. Yes, ma'am. Sure. You need change? Bless you. Do you have a Sharpie? Write your name on it. Good thing I do. I'd like to see something.
We go on the wall.
Once I do that, I sell tons of these. Yes, sir.